refresher of all of the properties here. So when we have exponents, the thing on the bottom is called the base, and the exponent is the little number up top, right? If we have two things that have the same base, so like here, these are both x's, so they have the same base, and we're multiplying together. Anyone remember what you do with the exponents when we're multiplying? You add them, right? So when we're multiplying two things, but they do have to have the same base, don't take that for granted, same base, and then we can add them. So here we would add 3 and -1 together, and we would get x squared, okay? If you have one base, it's raised to a power or an exponent, and then raised to another power or exponent. That's when you get to multiply those exponents together, okay? So double exponent is when you get to multiply. So here we have one base x, 4 power, and then to the squared. And so then you multiply, so it'll be x to the 8th. If you have multiple things inside being multiplied together and a power outside, you can distribute that power to each of the things inside. So here, x and y, everything inside here will be raised to the 4th power when it's multiplication. So x will be raised to the 4th power, and y will be raised to the 4th power. If there was addition in there, that would change things. But as long as it's all multiplication, you can do anything in there to the 4th power. Negative exponents, this is probably one of the trickier ones to remember. We don't want negative exponents in our answers. I like to think about negative exponents as moving it to the top or the bottom of the fraction, okay? So if something's in the top of the fraction, it has a negative exponent. If you move it to the bottom, and that will change the exponent to a positive. If it's in the bottom of a fraction and it's negative, if you move it to the top, that will change the exponent to a positive. So this guy right here doesn't look like it's in a fraction, but any number we have is always over 1. We can always write it over 1, right? If we want to 3, we can write it as 3 divided by 1, because 3 divided by 1 is just 3. So then if we think about it in the top, if we want to get rid of that negative m, we move the a to the bottom, and then we can change the m to a positive. If there's nothing left in the top, we leave a 1 there. So here, if we write this x squared as over 1, if we want to get rid of the negative exponent, we move the x to the bottom. That turns it into a positive, and then we leave a 1 in the top. We'll do some practice with those. Anything to the 0 power. Doesn't matter how big the number is. If it's 800 million to the 0 power, it's always 1, okay? Could be 7 to the 0 power. Could be 12 to the 0 power. Could be a giant number to the 0 power. Could be a negative number to the 0 power. It will still be 1. It could be x, y, and z all to the 0 power. That will still be equal to 1, okay? And then I think you remembered that when we multiplied, we add the exponents. Anyone remember what we do when we divide? We subtract, right? But they have to have the same base. Don't take that for granted. You can only do that when they have the same base. So here, these both have the same base x, so we can subtract exponents, and we'll have -3 minus a -6. That'll turn into +6, and so we'll get x to the 3rd. And just like multiplication, if you have a bunch of stuff divided inside, all of that can be raised to that power. So here, both x and y inside are squared. The x is squared and the bottom is squared. Okay, so let's actually try to put these in action here. The instructions for these kinds of problems will be simplify. One thing this means automatically is no negative exponents. You don't want any negative exponents in your answer. So for question 1, do these two things have the same base? Yeah, they're both base y. We're multiplying, so what do we do with the exponents? Add. So this will be y to the 7 plus 5, or y to the 12. For number 2, these also have the same base. They're x's, and we're multiplying together, so we can add those exponents together. And some of you are like, why, Mrs. Castillo? Why do you have to put a fraction in there? Everyone hates fractions. Well, these fractions aren't that bad. This fraction's really nice. What's this fraction? 1. That's 1, right? 3 divided by 3 is just 1. So really, this is 1/2 plus 1. What are some different ways that we could write 1/2 plus 1? I think I heard 1.5. Did I hear 1.5? We can write it as 1.5. If you do it in your calculator, it's 1.5. You could write it as 1.5. 1 plus 1.5 is 1.5. If you write the 1 as 2 over 2, that's also 1. Then you could write it as 3 halves, because 1/2 plus 2 halves is 3 halves. So the most common way you will see this is x to the 3 halves or x to the 1.5. Go ahead and do number 3 on your own if you haven't already done it. Do these all have the same base? T, T, T. We're multiplying all of them together. So what do we do with the exponents? We just add them all up. So it'll be T, and then we'll have 13 plus 15 plus 18, which is 40, 46, right? T to the 46th power. So as long as they have the same base and you're multiplying them together, you can add the exponents. Any questions on those? Down here, what do we do when there's one base and we have double exponents there? Exponent to the exponent. What do we do there? Multiply. So that'll be m to the 3 times 2. That's when you multiply. You're not adding anymore. So m to the 6th. Because it's a power to a power. You're not multiplying m to the 3rd times n squared anymore. For number 5, we have a bunch of stuff raised to the 5th power. So everything in here has to be raised to the 5th power. So you're going to have a squared raised to the 5th power, and you're going to have b cubed raised to the 5th power. So you have to multiply the 3 and the 5 to get b to the 15. But you also have to multiply the 5 and the 2, since that's another power to a power. So that'll be a to the 10th. Another thing to just keep in mind here for the future is there's an invisible multiplication sign here. When we have these things sitting next to each other, that's multiplication, right? Same thing with our answer. There's a little invisible multiplication sign here when we have those sitting next to each other, which is why we're able to do the power to everything inside. Any questions about number 5? Okay, go ahead and do 6 and 7 on your own if you haven't already. Just take the hall pass. So this should be x to the 12th. We're multiplying those exponents together because it's a power to a power. And here, when we're dividing, what are we doing in number 7 with our exponents? Subtracting. So that should be x to the 6 minus 5, or x to the 1. However, a lot of times, we don't write our answer as x to the 1. We're not going to see it written that way. How are we usually going to see that written? Just x, right? So anything that doesn't have a power, you could fill in a 1 if that helps you, or if it has a 1, that means it's just that thing. Okay, now let's try to do a couple where we're putting this stuff together here, okay? So here, we definitely are dividing, okay? So we're going to be subtracting. But should I subtract 25 minus 5? No. Why should I not subtract those? I thought when we were dividing, we subtracted. Those are not exponents, are they? Are those exponents? Are they little baby numbers in the top, this 25 and this 5? No, those are coefficients, okay? They're numbers in the front. In fact, remember, there's a little multiplication sign between all of these things, right? This 25 is not tied to the x to the 5th. That x to the 5th is its own thing. The 25 is its own thing. The y to the 5th is its own thing. So there's 3 things in the top there. 25, x to the 5th, and y to the 5th. And they're all separate. They're all being multiplied. And in the bottom, there's 3 separate things. 5, x squared, and y cubed. They're all being multiplied. So what do I do with the 25 and the 5 instead? Divide. That's what this symbol says to do, right? They're just numbers. They're just coefficients. So 25 divided by 5 is 5. Then we'll move on to our x's. Then since we're dividing, what do I do with the 5 and the 2? That I get to subtract because we're dividing and they have the same base. So that'll be x cubed. And then what can I do with the 5 and the 3? I can subtract those because these have the same base, right? So this is why it's important to pay attention to the base, right? These are being divided same base, so we subtract their exponents. These are being divided same base, so we subtract their exponents. And then that's my final answer. Any questions on that one? All right, try 9. Be careful. I tried to trick you. Do I subtract 28 and 7? What do I do with 28 and 7? Divide. Those are coefficients. They're separate. They're their own thing. 28 divided by 7 is 4. Do I subtract 6 and 2? No, I do not subtract 6 and 2. Why do I not subtract 6 and 2? Those are different bases. Remember, it matters what the base is. Do these have the same base? No. These two have the same base, right? So what can I subtract for the y's? 6 and 4. So the y will be 6 minus 4, and the x will be 5 minus 2, because those are the ones that have the same base. I'm not just saying the same base all the time for no reason, right? It actually matters, okay? And so your final answer should be y to the 4y squared and x to the 3rd. If you had 4 and 1, that's because you didn't pay attention to the same base, right? They have to have the same base to be able to subtract the exponents. Any questions on that one? All right, let's mess around with a couple negative exponents, and then you'll try and see if you can do a couple on your own, okay? So remember, to get rid of a negative exponent, I want to move it to the bottom. This guy isn't written as a fraction, so you can write it as a fraction. Anything can be written over 1. So it's in the top. So I will move the t to the bottom, turn the negative 1 into a positive 1, and then there's nothing in the top left, so I will leave a 1 there. However, usually we won't write our answer like that. Instead of t to the 1, we're just going to write what? Just 1 over t, right? Usually when there's a 1 power, we're not going to write that. We're just going to write 1 over t. So try 11 and 12 on your own. All right, so 11, you can write that over 1 if you want. So the m's going to move to the bottom, and it will be a positive 2 now. There's nothing left in the top, so we'll leave a 1 there, and there's not really anything else I can do there, so that's just 1 over m squared. For number 12, though, the z is in the bottom, so we're going to move the z to the top, and then it becomes a positive 3 if I move it to the top. There's nothing left in the bottom, so you can leave a 1 there, but are we usually going to write it as z cubed over 1? Is that how we'll see it? No. How will we just see it? Just z cubed, right? Because anything divided by 1 is just itself. Now be careful, you can't let this 1 go away, right? If you have, for example, 3 over 1, 3 divided by 1 is just 3, right? So I can let that 1 disappear. But if I have 1/3, can I let that 1 disappear and just become 3? No, that's a different number, right? So just if you're dividing by 1, are you allowed to do that? Any questions on those two? All right, let's see if you can put it together now. So on the next page, I want you to do 13, 14, 15, and 16. See if you can try putting it together. We'll go over it here in a minute, and I'll be walking around if you have questions. But I want you to try. So that you can see which parts you got and which parts you need to work on, right? So the first one, I think a lot of people had x to the 6th and y to the 9th. Raise your hand if that was part of your answer. X to the 6th and y to the 9th for the first one. Raise your hand if that was part of your answer. I think a lot of people got that. You did that because you were doing x squared to the 3rd power and y cubed to the 3rd power. Even if you didn't write down that step, right? You were raising this to the 3rd power, so you multiplied 2 and 3. You were raising this to the 3rd power, so you multiplied 3 and 3. However, the number in the front is where we tended to differ, okay? Because that 2 is separate. It's not attached to the x squared, right? It's its own thing. There's an invisible multiplication sign in between all of 3 of these things. So there are 3 things here that you need to raise to the 3rd power. You need to do x squared to the 3rd power. You need to do y cubed to the 3rd power, but you also have to do 2 to the 3rd power. And you shouldn't be multiplying this 3 and this 2 because this 2 is not an exponent, right? That's a coefficient. So you should be raising it to the 3rd power. You should not be multiplying. And 2 to the 3rd power is 2 times 2 times 2, which is 8. Okay? 2 to the 3rd power is 8. Now, let's say we have really big numbers in the future and that's kind of hard to do, so you want to use a calculator. On these calculators, I'll show you how to do a power, okay? If you want to do 2 to the 3rd power on one of these calculators, you're going to do 2. There's this little caret symbol, this little arrow here that looks like this, and then you will do 3. So that's 2 to the 3rd power in one of these, and you would get 8. So if it was like a bigger number, not easy to do in your head, that's how you would do that, 2 to the 3rd power on these calculators. So this is the answer for 13. I think the beginning number was the only thing that really tripped people up. Any questions on that one? All right, 14. We have 2 things happening here. We have an exponent here that we have to do to all of this, and then we have to multiply these together. Which one of those should I do first, the exponent or the multiplying? Exponent. PEMDAS says exponents first, right? And then multiplying, which I think most people did. So you should have x to the 10th, w to the 4th, and then remember there's a little invisible 1 here with the z. So that should be a z squared just from this part. So check to make sure you had that part just from the exponent. Any questions about how I got that from just the exponent part right here? Then we're going to multiply by 2x cubed w. There's a little invisible 1 there. And an x squared. So now I'll multiply. And this is a multiplication symbol, but remember there's also multiplication symbols between all of this. So all of this is being multiplied together. If there was a coefficient out here like a 5, you would multiply that coefficient with this coefficient, okay? Because those can multiply together. If it's helpful for you to think about a little invisible 1 coefficient in the front, you can do that. So our coefficient in front of our answer will be a 2, because 1 times 2 is 2. There's nothing for this to multiply with. For our x, what will be our coefficient for our x? Hint, it's not 13. It's 15. Because we have x to the 10th, we have x cubed and x squared. And those are all being multiplied. So what do we do to exponents when we're multiplying? We add their exponents. This is being multiplied, this is being multiplied, this is being multiplied. There's no plus symbols in here, right? It's all multiplication. So we're going to add all of those exponents. So it should be x to the 15th. We also have some w's that we're multiplying together, so we'll add those exponents, so that should be to the 5th power. And then there's nothing to multiply the z by, right? So it will just be z squared. And so this should be your final answer. We're not combining like terms here, right? Like, this isn't like what we did the other day. There's no addition and subtraction. This is multiplication. And when we multiply things that have the same base, we add their exponents. These 3 have the same base. These 2 have the same base. And this one doesn't have anything that has the same base. Any questions on that one? Okay. I saw for number 15, I saw this a lot of places. Raise your hand if you had this as your as at least one step. Not your final answer, but at least a step on number 15. Did you have this at least a step? Okay. So we divided 15 and 3. We didn't subtract, right? Because those are coefficients. We subtracted 4 and 6, and we got -2. You have to do it in that order, top minus bottom, okay? And then 7 minus 4 is 3. Can I leave my answer like that, though? No. I need to get rid of the negative exponent. So where does this go? Since it's negative, it's got to go to the bottom. But what is the thing that has the negative exponent? It's just the x. Does the y have a negative exponent? Does the 5 have a negative exponent? No, the 5 doesn't have a negative exponent either. Remember, these are all 3 separate. There's multiplication here. So here in my answer, there's a 5, there's an x to the -2, and there's a y cubed. That -2 only belongs to the x. So what's the only thing that's going to move to the bottom? Just the x, not the 5. Don't take the 5 with it. It doesn't belong there. Don't take the y. It doesn't have a negative exponent. Leave those 2 in the top. Just the x goes to the bottom and becomes positive. Because this negative exponent only belongs to that x. That's the only thing that has a negative exponent. So a lot of people got here, I think that last little part just kind of messed them up a little bit. Does that make sense? Why we only move the x? And then 16 feels a little weird. If you didn't get a chance to do 16 yet, ignore the 2/8 and just try to do the second part. At least the x's and the y's. Tell me what your x should be and what your y power should be. Yeah. So for the first step only, right? 4 minus 9 will give you -5. 7 minus 4 will give you 3. And now what's weird about 2 divided by 8 that makes this one a little bit trickier than the last ones we've done? Is that a nice number? 2 divided by 8? No. It's a decimal, 0.25, right? You type it into your calculator, okay? It's not a nice number, right? If you do 2 divided by 8. So you could write a 0.25 in front of there and you would not be wrong. That would be correct. But that's not how you're going to see your answers. So I want you to do it a little bit of a different way, okay? And so what I want you to do is I want you, when your division doesn't happen nicely, when it gives you a decimal, I want you to simplify that fraction. So I know it's been a hot minute, so let's refresh on how to simplify a fraction. If I want to simplify a fraction, I want to find a common factor with both numbers. So what number are both of those divisible by? 2. 2. So divide top and bottom by 2. 2 divided by 2 will be 1. 8 divided by 2 will be 4. So this fraction simplifies down to 1/4. Okay? So the coefficient in the front will be 1 over 4. That's the same as 0.25. Okay? So if you put a 0.25 there, you're not wrong, right? We're just usually going to see our answers as fractions. Okay? But we're not done, because what do I not like in my answer so far? The negative exponent. So where does that x need to go? To the bottom. But we already have something in the bottom. What do we have in the bottom? A 4. So we're going to put that x in the bottom with the 4, and the y is going to stay in the top with the 1. Okay? So the y is going to stay in the top with the 1. The x is going to go to the bottom with the 4, and that will become a positive 5. But usually you're not going to see that 1 in your answer. You're just going to see a y cubed over 4x to the 5th, because that's just 1 times y cubed. Any questions on that one? Okay, we're just going to do 4 more little negative exponent ones just to make sure you understand these. The last 2 are just kind of for you to try if you wanted to try them. It's not necessary that you do them today. So we're going to talk about these next 4 real quick before we go. So here with 17, there's only one simple thing that we're going to do. That whole thing is being raised to the 3rd power, so the x will be raised to the 3rd power, and the z will be raised to the 3rd power, and that's it. Except you can't see. I wonder if my internet disconnected. Yep. Okay, so this will be x to the 3rd power over z to the 3rd power. What's k to the 0 going to be? What's anything to the 0 power? Just 1? And then for the last 2 here, okay, there's a couple different ways you can think about 19 and 20. I'm going to do it one way, but if you try something else and get the same answer, that's fine. We're going to first do everything to the negative 3rd power. So the 1 will be to the negative 3rd power. The k will be to the negative 3rd power. But do I want negative 3 in my answer? So where's the k to the negative 3 going to go? To the top. And then the 1 to the negative 3 will go to the bottom. So they're just going to switch spots. So the k to the negative 3 will come to the top. That will become positive. The 1 to the negative 3 will go to the bottom. That will become positive. 1 to the 3rd is just 1 times 1 times 1. So what's that? Just 1, right? So this is just going to be k to the 3rd over 1, which is just k to the 3rd. That's usually how we're going to see the answer. Just k to the 3rd. So if you want to think about flipping the fraction first and then raising it to the 3rd power, that's also fine. So go ahead and try 20. Last one to try on your own. So first it will be w to the negative 2 and x to the negative 2. We don't want those negatives in our answers, so they're just going to switch spots. And this will be your final answer. Any questions on those last couple? Okay, if anyone tried 21 and 22, I'm going to put the answers up here so you can check it if you're interested. If you did not try 21 and 22, that's fine. Don't worry about it. You don't have to. The bell's going to ring here in a second. Don't forget, if you want a paper copy of the homework tonight, they're in the blue crate. We will practice tomorrow before we do the homework quiz. So we'll have a warm-up and some practice. Yes.
So you can have a -2 on the top?
Yes, because that's not an exponent.
Oh, okay.
Great question.